Good afternoon and good evening, ladies and gentlemen from all over the world. Welcome to the launch event of Ecologist Optimizer, your sustainable supply chain management expert. I'm Yu Huang, the project manager and hostess for this event. Schneider Electric has the prestige for its sustainable development and supply chain management. For these two areas, Gartner's annually released Global Supply Chain Top 25 list will definitely have a say. And Schneider has been strong on that rank, reaching the first in 2023. Also, Schneider has been recognized by other sustainable development evaluation lists in the right-hand side. Schneider has been doing great, but does that mean it's enough for Schneider to keep the throne or achieve even greater sustainable development goals? Or is there any underlying challenges? We will see in a minute. From internal perspective of Schneider, it does use some logistic management systems like Control Tower. But the isolation in subsystems of Schneider's smart distribution centers and factories, as mentioned in the case. And from external perspective, third-party logistic companies connect Schneider with its upstream suppliers and downstream customers. But some logistic companies' transportation management systems are not integrated or connected with Schneider's. And even worse, part of the logistic process are not digitalized. This is very hard for Schneider to go further on its digital-driven sustainable development path, causing decarbonization problems. These internal and external information silos will generate inaccurate predictions. And what's worse, the optimization algorithm of existing systems are not carbon-oriented. And even if the logistic managed systems are carbon-oriented, they can't generate accurate predictions with fragmented information. So after thorough investigation and discussion, we propose our solution. Ecologist Optimizer. It can interact not only inside Schneider's factories and DCs, but also connects the whole supply chain. We define Ecologist Optimizer as an intelligent transportation and logistics expert with the help of Internet of Things, AI large models, and interconnected databases, and digital twin technologies. And in its technique flow, Ecologist Optimizer first automatically connects data from Internet of Things system, and part of which will be inherited from Schneider's current EcoStruxure platform, and part of which will be newly installed. And then the data will be cleaned, installed, and integrated into the interconnected databases, waiting to be extracted for our AI optimization algorithm. And our Ecologist Optimizer fully considers our 4-tier optimization elements. That is the transportation mode and the fleet configuration, including the size of the truck and the energy type they use, and the route selection, and finally the carriage loading configuration. Under these 4 optimization algorithms, Ecologist Optimizer minimizes costs and carbon emission together, and can make logistic predictions. And for its display and interaction functions, users first input their demands like transportation origins and property of goods, time and cost, and so on, just using natural language to talk with our Ecologist Optimizer as you are the boss. Your smart logistic expert will take care of all, including the simulation, the optimization prediction, and emergency alarming. And it will always be at its best to be your personalized logistic assistant, and not only thinks ahead and plans ahead, but also provides intimate service with those context-based executive plans. And now, let's come to what we can expect from our solution. Ecologist Optimizer is a pain reliever to connect information silos and minimize carbon reduction, as well as a gain creator to generate extra benefit. Let's welcome Yunqing, our sustainable and financial advisor, to introduce more about this. Hello, everyone. I will introduce more about our system as the pain reliever and gain creator. As mentioned above, we will use interconnected databases and Internet of Things to collect real-time data to connect Schneider's internal and external users to solve the information silos. Then, through collaboration and real-time optimization, our system will play a pain reliever role in decarbonization. Overall, the most carbon reduction is from our full-tier transport optimization model. First, we use the multimodal transport mode to replace the existing truck-only mode, which is estimated to reduce carbon dioxide from 40% to 80% by rail and water transportation. Then, our system will configure electric trucks to replace diesel trucks, which could reduce around 30% carbon dioxide. With the development of new energy power generation, the proportion will be higher. Further, our model incorporates the road and carriage configuration optimization with a digital twin, expecting to reduce more carbon dioxide in practice. Moreover, there are many other potential carbon reduction areas under our upgrade intelligent logistics management, warning system, and unified order management, which could reduce repetitive or unnecessary transport, increase transport efficiency, and enhance transport emergency response capabilities. Therefore, by integrating the proportions of different parts, we conservatively estimate our system could reduce 40% to 80% of carbon dioxide emissions of Schneider after our system is on track. What a helpful pain reliever for Schneider to achieve its ambitions in decarbonization. Then, how much investment do you think the significant carbon reductions will require? The answer is that the cost will be easily covered after smooth operation, even generating benefits in the future. First of all, let's focus on our costs saved from transportation. In line with our full-tier transportation optimization, there are full-tier cost savings. Based on the case of Wuhan and Shanghai, we estimate that using water and rail to replace trucks will reduce 8% to 50% carbon cost per time. Further, considering the operating expenses, the residual value of diesel trucks, and excise investments in electric trucks, we estimate there will be around 70% reduction in cost per time. Further, according to research, the cost saved from road and configuration optimization will be around 10 to 20%. Therefore, our cost saving is conservatively around 50 to 60%. Additionally, our system can save costs from advanced preparation in emergencies, better order forecasting with lower inventory holding costs, and original expenses in similar functions. Then, we incorporate the initial investments and following expenses in the figure. And you can find that even adding these expenses, our solution will not affect the profitability of Schneider and may generate several cost savings. Further, you don't need to worry about this estimation because we have considered these parts of expenses in the cost constraint of our model. Finally, with the launch of the shared system, the usage of membership fee will generate continuous revenue for Schneider. Thus, after the system is on track, it will become a profit creator for Schneider. Ecologist Optimizer, as a gain creator, will also support Schneider's leadership position and ongoing growth. The supports are from resilience in emergencies, agility in interaction, and lower risk in implementation with compatible module and employee-friendly interfaces. Thus, as a gain creator, our ecologic optimizer is expected to be a capable logistic assistant in sustainable development. Finally, I would like to give you a more intuitive feeling of our innovation and necessity by comparing it with other products in the industry. You can find that no matter the degree of intelligence or comprehensive or foresight in functions, our ecologic optimizer is superior to others. Therefore, we have confidence in our success in supporting decarbonization as a pain reliever or promoting sustainability as a gain creator. Well, I have provided lots of information for you. Let's welcome Yue back to give more details about our implementation. Okay. Thank you, Yingqing. That's very detailed introduction and analysis. So let's show you how our project is going to be implemented. So we propose a point, line, and surface action plan, and we choose 2025 as the first stage year. And by that time, Ecologist Optimizer will have been connected in Schneider's two major smart distribution centers in Wuhan and Shanghai. We estimate that until then, we will reduce more than 50% of carbon dioxide emission, considering the large freight volume of both distribution centers, which will definitely meet Schneider's carbon reduction target for the year 2025. And from the year 2026 to 2030, we will reach out to our upstream suppliers and downstream customers in Schneider's whole supply chain, not only in China, but also globally, with more our third logistic companies involved. And the estimated carbon reduction is around 40% to 80% in China. By the year of 2035, 35, we have the ambition to popularize our system to other entities, like other manufacturers other than Schneider, and government and universities around China and around the world, basically just outside Schneider's own manufacturing and logistic chains to achieve greater carbon reduction targets. And through the three stages, Ecologist Optimizer have a significant industrial-wide impact by promoting data sharing and supporting grassroots participation, and also achieve an industrial-wide decarbonization. And as for the locations of our global promotion, we would first prioritize Schneider's own 4 hubs, starting from China, obviously, and then to Europe, India, and North America, and then to other promising markets like Africa and Asia Pacific. And finally, from the properties of our system and planned actions, our solution will support almost all aspects of SDG 9 and many aspects of SDG 4, 8, 12, 13, and 17. And that's a very conservative and overview of our project. And let's hear from our boss and customers. First, let's welcome Schneider's Board of Director representative, Ms. A, and our teammate, Hao Xiang. What's your opinion about our project?
At the site of your proposal, I sense the revolution in Schneider and the whole industry. The wind of change is blowing.
Thank you, Hao Xiang. And let's hear from our representative from logistic companies. Hi, Jiaying, what do you think of our project?
I'm so impressed about it after this presentation, and I'm so interested in it. So, Ecologist Optimizer is the optimal solution. It allows me all the logistic information at hand. Where's the contract? Let's sign now.
Okay, thank you, representative. Okay, so that's the end of our presentation, and thank you, honorable judges. The floor for questions are open. Thank you.
Okay, well, thank you very much for the interesting presentation.
Thank you.
We will move to the question and answer period.
Of course. Yeah.
Dr. Damia, do you have questions for the students? Dr. Damia, can you hear me? I see you online. Oh, perhaps you cannot hear me. Okay, well, I will then start with the questions, and hopefully you will come in with some other questions as well. On one of your slides, when you show the pyramid where you have the multimodal transport on the bottom and you move up.
Yeah.
Is it my understanding that it's the steps, what you're representing, is these are steps implemented? You start with the multimodal, then you move up the pyramid, or is it the other way around, or is it going all together? Can you explain that more in detail?
Okay, thank you, sir. So that's about our 4-tier optimization of our cost and also the decarbonization problem. So let's welcome our model master to answer this question. Yeah.
Thanks for your questions. About this 4-tier optimization, it's not a step-by-step. We considered all 4 aspects of this about the multimodal transportation and electric and so on. The 4 aspects all integrated into our models in the Appendix A. Maybe you could see it in the written submission. And you find that at the same time, therefore, we consider the all 4 aspects at the same time. For why we represent about the 4 steps like this, we want to show you more clear about each step, but then to summarize the total carbon reductions from our optimization. Therefore, this is just a representation with, but in the reality, we will integrate the 4 aspects to our integrity models, and we will optimize them at the same time. Yes.
Okay, thank you, judges. And I'll have something to add, as that my teammates has also mentioned that the 4 aspects will be integrated and optimized at the same time. And our 4 layers just want to show that they have different potential to decarbonize as we put the multimodal transportation at the very benchmark proportion of the pyramid. And it shows that, I remember it has the potential to reduce carbon to 40 to 80%. And because the multimodal transportation just influence a lot. And then as we get upstairs to the upper layers, their proportion of decarbonization may be shrink a little bit. So not so big decarbonization potential as the multimodal transportation. Yeah.
Okay.
Just
I
to want to show the
and,
proportion. Yeah.
It's really understand that the transportation aspect of a supply chain is the biggest contributor
sure.
to carbon emissions. But my question is, why do you think multimodal can provide such a large reduction?
Okay, so thank you, judges. And for multimodal transportation, we would like to define here that what kind of mode we actually considered. So for Schneider, it currently use truck and mostly use truck to transport its goods. But then we considered the train and which is the high-speed train or the just normal the coal-fueled train, and also the waterway, the ships. So we combine the 3 modes together, and as the trains and also the ships, their carbon emission is just lower than the traditional diesel trucks. So we would like to propose this multimodal transportation that includes ship and train at the same time to just shift to another mode that could greatly reduce the carbon. And compared with our EV truck, because it takes time and it's slower than the implementation of multimodal transport. So we considered it in the 2nd tier of our model. Yes.
Okay. So I'm going to drill down a little bit more on this multimodal. Now, based on the information, I know in the case there's some information given about the weight of the freight and the distance it travels. Did you analyze that to look at how much of the freight could be converted to other modes other than truck? Because as you know, each mode has its own characteristics. So what percentage of that freight could be transferred to other modes?
Okay, thank you, sir. And for our multimodal transportation, surely we need to consider the proportion, and we mostly we would propose the train transportation mode, because we actually are aware of that. There is an issue concerning the water freight, that because Schneider itself is a electric related or electron related production company, that if it chooses a lot of the waterway, and there's a potential that the water will damage the goods or so on. So we may suggest that the proportion for the shipment is a bit lower, and the proportion for train transportation will be larger. And we haven't figured out the exact proportion and in our model. So maybe in that aspect, we could invite Yunqing to elaborate more on that.
Okay,
Hello, in our model, we say that our carbon reduction is the total amount. Therefore, we consider the proportion that we could change or shift our current transport mode to our multimodal transport mode. And therefore, we set this proportion of considering these problems. And therefore, we don't think that all our products will shift to the train or the water. And we just think maybe just 25% will change because of we calculate that our weight is about at a range from 100 kg to 400 kg, and this volume, this weight is suitable for the train and the water. And I have found that there are many maybe types of containers to avoid the things like the water damages to the electric equipment. Therefore, we think we have considered this in the proportion to generate our final carbon reduction.
Yes, sure. Thank you, Judge.
I think we have a question from Mr. Dr. Dania. You go ahead with your question.
Yes. Hello, everyone. Once again, thank you for having me here, and thank you for a wonderful presentation indeed. Other than that, there wouldn't be any questions to you if the presentation wouldn't be interesting. Well, first of all, thank you for bringing it. The decarbonization is the #1 priority, and thank you for touching this subject. Maybe you have heard about the fact that the Maersk launched first ever zero-free vessel, which is something new for the world. So my question is like that. You perfectly defined the model, and I just want to understand your perspective. When it comes to the transport and logistics, right? There we broadly can say that there are two determinants, right? Cost and time,
Yeah.
right? So
Cost
I
and
just
time,
wanted, yes, I just wanted to understand when it comes to the diversification, what you mentioned, right? The Schneider will not be 100% moved from the ocean to multimodal or vice versa, right? The diversification is always good idea to hedge the risks,
Yeah.
right? But
That's true.
based on your perspective and considering the cost and transit time importance, have you seen what kind of approach for the next upcoming 10 years Schneider should consider as a transport mode? Should it be for the particular markets only multimodal solution, or it should be from 99% ocean, if the ocean is going to decarbonize under the decarbonization policy? So the main question is, how you think Schneider should move their transport mode for one particular transport mode? If no, if yes, okay, but if no, why?
So from my understanding, you honorable judges would like us to justify why Schneider doesn't have the reason to switch it just need to stick to one transportation mode, right?
Correct. Correct.
Okay. So as Maersk, I know it's a very international and very professional shipping, overseas shipping company. And as you mentioned, you proposed the decarbonization and clean energy vessels. So if we would have to justify that, we would say there are several factors we would consider. So first of all, the switching cost is definitely something we would consider, because if we propose a multimodal transportation, there has to be some switching costs from one mode to another mode in one shipment. So from one starting point to one end. So the switching cost between one journey, they will be high. So this is the one consideration. And also, only use one transportation mode will make it easier to actually carry out our proposal, because it will be easier to implement our Internet of Things system, and also to connect our system and trace the whole process with our digital twin technology. And this implementation will be easier for us. And so we actually considered to switching from one not so clean vessel to one very clean and very green vessel. For example, we propose to switch to the diesel truck, to the EV truck, and just like you proposed, we would like to consider the traditional ship, the overseas ship, to your masks ship. And these kind of consideration can be integrated to our ecological system, and our algorithm will propose if the scenario is good for us to use a multi-modal transportation, considering the cost and feasibility of the data and the infrastructure. And also, if it's more economic and more feasible for us to use just only one mode of transportation and use clean energy, then why don't we just use it? So yeah, so that's has been integrated into our consideration, and thank you for raising that question.
Thank you.
Okay, that's great. That's about all the time we have for questions for today. So thank you
Thank
for
you.
the presentation, and thank you for the great question. So the results come out in about a week, and hopefully we'll see you do very well. Again, thank you very much, and goodbye.
Thank you, honorable
Thank you.
judges. Thank you.
Good luck.